Good morning, developers. If you are new to the channel, my name is Rob, and it is Algorithm Monday, and today we are going to look at Radix sort. It is a sorting algorithm, and if the only thing you care about is, Rob, explain it to me and show me how to code it out in Python, you can skip to the next chapter to give you a little bit of background about it and why we're doing it. The sorting algorithm is kind of a cornerstone of almost any computer science program. You've got a list that's not in the order that you want it. How do you get it into the order that you want it as efficiently as possible? And efficiency can mean a lot of things. It can mean the shortest number of steps. It could mean speed. It could mean memory usage. It could mean processing power, etc. Big O notation, I don't have a video on that, but I will make one, and once I do, I'll come back and link it, is a way that we have come to identify how efficient a given algorithm is. And the ones that you probably know of, if you know of any, bubble sort is the first one I teach because it is so simple, easy to understand. It is not efficient, so it's not really used all that often in industry. The three big ones tend to be insertion, quicksort, and merge sort. And Python uses a combination, I think, of merge and insert, at least as of making this video. In JavaScript, if you use sort, the sort function, in I think all of the browsers, including Node, it is some version of merge sort. And it's because they're so consistent. They're so predictable in the way that they're going to behave across almost any data type. Radix is one you probably haven't heard of. And it happens to be a non-comparative algorithm. And when I first heard that, I thought, what are you talking about? How can you sort a list of things without ever comparing them to each other? And like all the sorting algorithms, it is brilliant. And it has a big O of n times k. And n is the number of items in the list, okay, right? We have to at least always go through all of the items. K is the number of elements in the longest item. So we are going to do strings. So k would be the longest string, the one with the most characters. If we were doing integers, it would be the number with the most digits. Okay, so you multiply those two together. And this algorithm really shines, really performs well if you have a large data set and each element has a generally short length. So if you're a subscriber, you might have expected this video to be about Project Euler number 22. That's coming, but we have to do some sorting in that. And instead of using the Python sort function, we are going to use the Radix sort, and it's a perfect use case. We have 5,000 names that range from like 4, maybe 3 characters out to 8 or 9, I can't remember, but it's a great use case for this algorithm. Okay, so how does this work? Well, let's get ourselves a list. We will have dog, cat, frog, cow, and bat. So they're good and mixed up. We've got a little bit of variety, a little bit of synergy. We've got a cat and a bat, so AT and AT with a different starting. We've got dog and frog, different number of letters. We've got cow with an O and dog with an O in the same spot. Okay, the first thing we have to do is figure out what has the most characters, and that's frog. So we're going to iterate through this 4 times, starting at the farthest to the right. So we're going to grab the 4th character in all of these, and we're going to put it in a corresponding bucket. Now, I'm only going to draw up the buckets that we need, but we will make 26 different arrays, and as we loop through, we'll drop it in that one. Let me make the buckets quick. So I've drawn our buckets out. Again, we will have 26. There is a version where you can do it dynamically and only make the buckets that you need based on the characters you have. It's irrelevant. 12 versus 24 is not going to make any difference at all in the speed of our program. You can notice, though, that they are in order. Other than like E is missing, right? A, B, C, D. The array is already in order. So once we drop them into their appropriate bucket, we're going to smash it back together, and you will see. We're going to start at position 4. Dog has nothing in 4, so we're going to put that at the end here. It'll actually be in its own bucket, but dog will end at the end, so we'll cat. G is our letter for frog, so that goes in the G column here, or the G bucket, so frog, and then cow and bat go at the end. They are now sorted based on their final letter. Okay, so we have finished 4. Now we take them and we smash them back together. So let me switch colors for this quick. We smash them back together, but we keep them in the order that they're at. So we don't have anything in any of these. Frog is now at the beginning. Dog, cat, cow, and bat. I know they're not in the right order, but they are in the right order for that last character. Okay, let me clean our buckets up. Alrighty, we are on to number 3, or index 3, position 3. And everything has 3. Okay, frog has O, so that goes into the O column. Dog has a G, so that goes into G. Cat has a T, so that goes into T. Cow has a W, so it goes into W. And bat has a T as well. Now, these are out of order, but they are in order for their farthest right character. Now, they happen to both have a T. We don't have anything else in the same bucket, but if we ever get going forward something in the same bucket, everything to the right will be in order, because now we're going to concatenate our list back together. So we're going to end up with dog, frog, cat, bat, and cow. And again, to the right of the third position, or the third position and fourth position, those are alphabetized, and we haven't compared anything. Okay, clean up the buckets again. We have finished number 3. We are on to position number 2. So we start with dog. That has an O, so that goes in the O column. We have frog, that has an R, so that goes in the R column. We have a cat, that goes in the A column. We have bat. Those are out of order so far. And then cow has an O. But if you notice, these two are the same, so they're still out of order. They've just been following each other around. Dog and cow, though, those are in the correct order for everything to the right of the O. The dog comes first and the cow comes second, because that last iteration, we ranked them based on that letter. That is why this works without ever comparing them. It still blows my mind, but we concatenate everything together. So we have cat, bat, those are going to switch, obviously, dog, cow, and frog. Now, again, I know these are in the wrong order and they are going to switch, but if we stopped here, they are sorted from the O on. We just haven't gotten to that last one. Let me get the buckets and we'll finish up. So we're going to finish up with number 1, and this is the most important one. They definitely should be in the right spot because we're working off of that first character, which is really, they better be in the right spot because we're putting them in alphabetical order based on the first one. Cat goes in C, so it's jumping over top of bat, except it's not, because bat goes in B, and when we concatenate, that'll be in front. Dog goes in D, cow goes below cat, and then frog goes in F. Last time I'll say this. Cat and cow, the reason those two are in order, they share the same first letter, but in that last iteration, we put cat ahead of cow, and when we smash them back together, that's why it's where it's supposed to be. If this was cow and this was cot, it would be exactly the same thing. They'd have the same letters for that second one, but they'd be in the right position. If this happened to be wow and this happened to be cow, wow would skip to the end. They would have been following each other until the very end. Again, hopefully you get the idea. We're sorting them in order per character, so they're always going to be on the top, sort of like bubble sort, floating up until we get to this last one where our order is correct. We have bat, cat, cow, dog, and frog. Okay? Let me clear this up and we'll pseudocode this out real quick. This is going to be more true pseudocode than what I would normally write because the sorting algorithm is a little more complicated. We need to do 2 things. We're going to have our list, and it'll have whatever it's got inside of it. We'll do A and B. You get the idea. We need to find the longest word. Okay, in our example, that would be the number 4. We need to pad the other words, because we don't want to have an index problem because we're going to be looking at a given index in a string. So we're going to need to make sure they're all the same length. And then we are going to loop backwards from our longest. So again, in our case, we're going to start at 4. So that's the position we're in. 4, 3, 2, 1, 0, and then we're going to stop. So we're going to hit, or I guess it'll be 3, 2, 1, 0, and then we'll stop. So we're going to hit all of our characters. And this is going to, each time through, we are going to call a function or something. So call bucket sort, something like that. And we'll make that function. And our bucket sort function we'll put down here, bucket sort. in here, each time, you could do it a number of different ways, but we'd have to clear it out every time. So what we'll do is we'll make 26 buckets. That's, rather than write it out, that's our bucket. And we're going to loop. So loop over the list, put word in the correct bucket, and then lastly we will return a concatenated list. All right, so up here when we call the bucket sort, when we return it, we are going to overwrite our list with whatever this returns. It's going to be our sorted list. Okay, that's it. That's going to be the whole thing. It's going to be super fast. It's not going to take very long to code. Let's go do it. I'm over to VS Code. Use whatever your code editor of choice is. Radix sort.py. I've got a start time and an end time to figure out how long it takes. We probably won't care about this, but I always include it in these videos. I already have a list together called animals. And you can make up your own list. You can obviously copy what I've got. Anything is fine as long as they're strings, because we're not going to handle numbers, and they also need to be all lowercase. You can modify it pretty quickly to include any letter, but just for simplicity's sake, we're going to stick with lowercase. And then I'm on my Windows machine, so I'm going to be using PowerShell. And we'll start off by defining a function called Radix sort, and we will expect a list to sort. And the first thing we need to do is get the longest element. So go into this list, which is going to be these strings here, and find the length of the longest string, so the one with the most characters. And so I'm going to define a variable called longest, and we're going to use list comprehension to do this. So we're going to use the max function, and we're going to hand to it length of string, and then we'll do a for loop, so for string in list to sort. So if you haven't seen me do this before, this is kind of a quick, clean way where this loop is going to run, and each iteration we're going to take the variable string, which will be cat and then bat and then dog and so on, and we're going to pass it to the length function. When we're done, this will create a new list, and we're going to grab out of that the biggest one. And I will print off longest so that you can see what it looks like. We need to call down below animals here our function, so let's do Radix sort, and we will pass in animals. Let's hop over and run our code, and there we go. We get 8 back, and that's because there are 8 letters in elephant. So that's our first task out of the way. The second one is we need to pad all the strings shorter than, and I'm putting in parentheses here, or in quotes, longest. So everything needs to be the same in order to keep from getting indice errors. And you'll see that when we get down a little bit farther. But we're going to take list to sort, and we are going to override it. And once again, we're going to use list comprehension. So we'll do string.ljust, which is justify to the left. We're going to hand that longest, and we're going to hand that the empty string like this. And then we're going to have our loop, so for string in list to sort. Okay, and there we go. So what this is going to do is it's going to grab, so just like before, we're going to loop through our list to sort, so one word at a time. We're going to take the word that we're on, we're going to justify it to the left, which means we need to say, how far out should I go? We need everything to be this long, and if it's not already that long, just start putting these at the end. So if we print off our list to sort at this point, these are our first 2 tasks, which actually is a lot of our programming. There we go. We get cat with 8 characters, bat, dog, elephant, and so on. Okay, so those are those 2 things out of the way. Now we come to our outer loop. So loop through the characters one at a time and bucket them. So we'll do for I in range. We're going to go from longest -1. We're going to go down to -1, and we're going to step up -1 at a time. So what this means is the strings are 8 characters long. It's going to go out to 8, which is actually, of course, the 7th indice. It's going to go all the way back to 0. It will stop when it gets to -1 and not include it, and we'll go backwards one index at a time. Inside here, we're going to take our list to sort, and we're going to set it equal to, we'll call it bucket sorter. We're going to pass it two things. We're going to pass it the list to sort as it is right now, and we're going to pass I, which is the position that we are on. We're going to start off at the last character, which will be the 7th index or the 8th spot, starting at 1, however you want to think about it. We're going to pass that I to bucket sorter along with the list. So let's go up top here and let's define our bucket sorter. Again, we're going to bring in, we'll just call it list this time, and we'll call this position. Actually, let's do care position, just so it's a little more explicit. Okay, we need to make our 26 plus 1 buckets. 26 will be for each letter A through Z, and then this is going to be for our space. For the cases back over here where until we get to the T, we need a place to put this. That's what that 27th bucket will be for. So we'll make buckets. We will set it equal to a list of lists, and we'll do for I in range to 27, and that'll do the trick. If we print off here buckets just to see what it looks like, we will have a list of 27 empty lists. So come back over here and refresh real quick. You can see that's exactly what happened. There's list 1, and each time through, this is a new character. We just haven't put him in their appropriate buckets yet. So our next task is to go through each word and grab the letter at position. Actually, I guess it's character position, and put it in the right bucket. So that's going to be for word in list, and we are going to make a variable called bucket index. That's the bucket that we want to go to for this particular character. We're going to use a function called ORD, and it says here this returns the Unicode code point for a 1-character string. So we're going to go to word, and we're going to go specifically to the character position. So we'll print this off here quickly like so, line 12, so that you can see what happens here. Run our code, and you see here we get 32, 32, 32, 116, and then more 32s. What's going on? Well, I have pulled up a table of all the ASCII values, and for the space here, this is the binary representation of space, this is the hex, this is the decimal version in ASCII. So a space is 32. We go down till we get to the lowercase letters. The T is 116. So what we've got here, instead of having to label our buckets and actually create a dictionary, whatever, which is really messy, we can just use the Unicode value here, the decimal representation of that letter. So this is going to grab the current letter, but we need to offset it by something, which means we're going to reset everything back to A. So we're going to subtract the value of A from everything. So if this happens to be A, it's going to end up in bucket 0 because it's going to be A minus A. If it happens to be B, it's going to be bucket 1 because it's going to be B, which if we come back over here, B happens to be 98, it's going to be 98 minus 97. So this is a clever way, at least I think, to get everything in the right bucket. We're going to have an issue though, because if we try and go to that bucket, so we're going to go now to buckets, and then we're going to go to bucket index, we are going to append the word. That's going to put it in the right bucket. This is going to create a problem because remember, 32 is what the space is, and we're going to end up with a negative number if we run this, which sure enough, well, it would be 97 minus 32, which is going to give us a negative index, so we get a range issue. So we're going to put right inside of our loop here. The first thing we'll do is we'll check to see if word at character position, if that equals the empty string. Okay? This is a blank. It goes in bucket 26. We don't have to do any of this other stuff. So we'll do an else, and I'll move everything over here quick. We'll grab line 16, and I'm going to paste it up here. We're still going to go to buckets, but we're not going to go to bucket index. We're just going to go to 26 because that's the last bucket, and append this particular word. Otherwise, do exactly what we just did. Use the character position to find the character in the word, grab its integer value essentially, offset it by A, and then that is the bucket it belongs in. So when we are done with our loop, I'm going to print off buckets, and we can see what they look like here. So my line 18, if we run our code again, alrighty, so the first time through, it put elephant here, which presumably is T because it's kind of towards the end. And then here you can see it just dropped everything else exactly in the order it already was. We're not returning anything, so it's the rest of the code is breaking, But this hopefully helps you see what's happening here. We've got, this was our empty list. I haven't commented that out yet. But this, we've got A, B, C, D, E, F, G, etc., all the way till we get to T, U, V, W, X, Y, Z, and then this is our empty space. Okay, so everything looks like it's doing what it's supposed to do. Let's concatenate our buckets. So step 2 is concat our buckets into one list. So let's create a variable, we'll call it result, and we will do for bucket in buckets. We will do result plus equals our bucket, and that will concatenate them together, and now we can return our result. So result is going to be the concatenated buckets, the buckets that we appended all the words to their correct bucket. It's going to come back, I guess, down here. List to sort is going to be updated. The bucket sorter, the next time we come up here, it's going to have a new index to send down, or a new position. It's also going to have a new list. So both of these are going to be new, going to come back up here. Everything, new list, new character position, so one more to the left. If we come down to the bottom here, actually let's do it up at the top. Let's do it after our loop is done. We will print off our list to sort, and if all goes well, clear that out, we get bat, cat, dog, donkey, elephant, giraffe, and horse. Everything is in the right place. So we have completed it. If you want to get rid of those pesky spaces, a really simple way to do that would be sorted list without pad. That's kind of a descript variable, but we're going to do word.strip open close. So again, list comprehension for word in list to sort. So this is going to remove the trailing spaces. And again, we're looping through list to sort, calling one more on word, and we're just going to run word to strip. So this is our final product, is the sorted list. I guess we can return that. Doesn't really make any difference. We'll send that back out. So down here, the value of this thing, sorted list equals that, and I'll print off sorted list like so. If all goes well, we should have our final list with no trailing or leading spaces. And it took 2/1000ths of a second. Our list isn't very big, but that is the Radix sort. The modifications you would make is if you wanted to include more characters, you can use this same ORD process that I used here. You just need to go out farther. You just need to make sure that there's always a match, and if there's not a match, you'll need to make a use case for it. You might want to do 2 lower because you'll have to deal with uppercase and lowercase and so on. But thanks for watching. The Radix sort is a great one to use. We will use it in Project Euler number 22. I will link that video when it is ready, but thanks so much for watching. Enjoy having another sort under your belt.